Hello. This video is going to go through how to find the 6 trigonometric ratios when you're given a triangle. So we have an example triangle here. As you can see, its sides are 3, 4, and 5, and we have our angle designated theta right here. A couple of important things to remember about trig problems are that we are going to be using right triangles. So every triangle should either have an obvious right angle or a right angle marked, which means you'll always be able to find the hypotenuse, which is the longest side, or the side that is across from the right angle. In this case, our hypotenuse is 5. As you'll probably remember, right triangles get the Pythagorean theorem. And so the Pythagorean theorem is that a squared plus b squared equals c squared. Or in other words, if you square the two legs of a right triangle, you will get the square of the hypotenuse. So we're going to do a little bit of color coding here. The two legs in this triangle are 3 and 4, and the hypotenuse is 5. To calculate the trig ratios, we're going to start with the 3 that should be familiar to you from Algebra 2 or geometry: sine, cosine, and tangent. You might remember the phrase SOHCAHTOA, or you can remember just that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Since you will be allowed to use notes on any projects and quizzes, I would definitely recommend writing these down for reference somewhere so you don't have to think about it when you're nervous on an assessment. To calculate sine of theta, you just have to identify which is the opposite side to the angle and which is the hypotenuse. Since we have designated theta, this angle up here in the top of the triangle, the leg that touches theta is going to be the adjacent leg. So our 3 here is adjacent to theta. The side that doesn't touch the angle is the opposite side. So for sine theta, we'll just fill in the values of the opposite side over the hypotenuse. Our opposite side is 4, and the hypotenuse is 5, which means sine of theta is 4/5 or 0.8. For cosine, we're going to do the same thing. We'll just use the adjacent side and the hypotenuse. The adjacent side is 3. The hypotenuse is 5, which means cosine is 3/5 or 0.6. For tangent, we'll be using the opposite side divided by the adjacent side. So our opposite side was 4, and our adjacent side is 3, meaning tangent is 4/3. You could write this as a decimal. It would be 1.3 repeating. In this case, it's probably better to just leave it as a fraction. Since this is an infinitely repeating decimal, you'll probably be tempted to round it, and 1.3 would not be correct. So those are the trig ratios that you remember, but as you might have noticed from the title of the video, there are actually 6 trig ratios. So there are 3 new ones that you will be using in pre-calc this year. They're called the reciprocal identities. As you might remember, reciprocal means to take a fraction and flip the numerator and the denominator. So each of the reciprocal identities is the reciprocal of one of the familiar identities. The first one is cosecant, and cosecant you calculate using hypotenuse over opposite. Notice that that's exactly the reverse of sine, which was opposite over hypotenuse. So when we calculate cosecant, we're going to use the same triangle, use the same numbers, but this time we'll have 5/4. To figure out secant, same thing. You can look up at the triangle to figure out the hypotenuse and the adjacent sides, or you can look at cosine. And we know that cosine was 3/5. Since secant is the reciprocal of that, our secant would be 5/3. And then cotangent is adjacent over opposite. The adjacent side is 3, the opposite side is 4. So cotangent will be equal to 3/4. Now let's do an example problem. So let's say you're given a triangle, you're given 2 of the legs, but you're not given the hypotenuse. In order to figure out all of the trig ratios, you're going to need to know all 3 sides. So you should use the Pythagorean theorem to figure out the missing side. We know that 6 squared plus 7 squared is going to be equal to the hypotenuse squared. So 36 plus 49 is 85. And that's equal to the hypotenuse squared. So our hypotenuse will be equal to the square root of 85. It's really likely when you're doing these problems that at least one of the sides is going to be an irrational number. That means it has a square root in it, which is why we've reviewed how to deal with numbers with square roots in it, because they're going to be coming up in these problems sometimes. To figure out sine, recall that sine is equal to the opposite side over the hypotenuse. Since this specifically says sine of A, it's going to be the opposite side with relation to A. So opposite A is side 7, which means sine of A is going to be equal to 7 over the hypotenuse, which is the square root of 85. For cosine, cosine is equal to the adjacent side over the hypotenuse. Again, we're looking at cosine of A, so with reference to angle A, the adjacent side is 6, the hypotenuse is 85. For tangent, we calculate that using the opposite side over the adjacent side. And so tangent is 7/6. Here are our reciprocal identities: cosecant, secant, and cotangent. Cosecant is the hypotenuse over the opposite side, or it is the reciprocal of sine. So cosecant would be the square root of 85 over 7. Secant is the reciprocal of cosine. Since cosine was 6 over the square root of 85, secant would be the square root of 85 over 6. Cotangent is the reciprocal of tangent. So since tangent was 7/6, cotangent will be 6/7. And that's how we find the 6 trigonometric ratios for A. You could have a problem that asks you to find trigonometric ratios for both angles in a triangle. And the great news is you can just use the same triangle, but you do have to be careful that when we're talking about angle B, we're going to be looking at a different adjacent and opposite side. So sine B is still going to be equal to the opposite side over the hypotenuse. But now to find the opposite side, we start from B, and opposite B is 6. So sine of B would be 6 over the hypotenuse. Cosine of B is the adjacent over the hypotenuse, and so the side adjacent to angle B is 7. Tangent B is opposite over adjacent, again with relation to angle B. So the side opposite B is 6, and the side adjacent is 7, which means the tangent of B is 6/7. You'll notice that I did not bother rationalizing the denominator here. There are several places where I do have an irrational number in the denominator. That's not going to be the focus of the video, so I'm going to leave it like that for now. There might be times when you're asked to rationalize the denominator, and in that case you wouldn't be able to leave your fraction with a square root in the denominator.